Welcome to Study Loop.
So we have tabulated values for alpha, rather the resultant acceleration squared, and then the delta theta squared. So we can say first r equals 0.80 meters, and then we can find a relationship for the resultant acceleration. So a resultant squared equals a uh, tangential squared plus a radial squared. At this point, we can say that the tangential acceleration is equal to r alpha, and the radial acceleration is equal to r omega squared. At this point, we can say a resultant squared equals r alpha squared plus r omega squared squared. We can find that omega final squared equals omega initial squared. The initial angular velocity is 0, so we can eliminate that term, and we can do plus 2 alpha delta theta. So we know now that the final angular velocity squared equals 2 alpha delta theta, and we can say that the resultant squared is going to be equal to r alpha squared plus 2r alpha delta theta squared. And we can now distribute the exponents and say r squared alpha squared plus 4r squared alpha squared delta theta squared. And this is your answer. Rather, this is how we're going to relate the graph to the equation. So if you were to graph this, we would have delta theta squared on the x-axis and a resultant squared on the y-axis. And if this is 4, 8, 12, 16, and this was the same, it would look somewhat like this if you were to graph it using Excel or your TID4, TID5, or TID9. And when we get the two variable statistics for this, we know that m equals the slope, and this is going to equal 0.921 meters squared per seconds to the fourth. B, which is the y-intercept here, would be equal to 0.223 meters squared per second fourth. And from here, if we say that this is y equals mx plus b, would model this function right here, and we say that here a resultant squared equals, again, r squared alpha squared plus 4r squared alpha squared delta theta squared. This means that the slope m is equaling our m here. So we can relate this equation to this equation, and m here would correspond to 4r squared alpha squared, which means that alpha is going to be equal to m over 4r squared all to the 1/2 power, and we can then solve. So this would be 0.921 divided by 4 times 0.8 squared, and we find that the angular acceleration is 0.600 radians per second squared. So this would be our angular acceleration. This would be our answer for part B, essentially. And at this point, we can say that if this is our answer for part B, and part A would essentially be this graph and this relationship here. For part C, it's asking us what would be the angular velocity at 135 degrees. So 135 degrees corresponds to 0.75 pi, given that pi equals 180 degrees. So our omega would simply be 2 alpha theta to the 1/2 power. And this equation is from this equation here. So we use this equation here for part C. And at this point, we can solve. So 2 times alpha, 0.6, and then times 0.75 pi. And we can do this all to the 1/2 power. And omega is found to be 1.681 radians per second. For part D, they're asking us for the angle between the linear velocity and the resultant acceleration. So we find that v is equaling to r omega. So we can do this really quickly. 0.8 times 1.681, and this is going to be 1.345 meters per second. And then we can say tan of phi. So tan of phi, phi will be our angle between the linear velocity and the resultant acceleration. And this is simply the radial acceleration divided by the tangential acceleration. We can find this to be r omega squared over r alpha, which is simply going to be omega squared over alpha, or 2 alpha over delta theta over alpha, 2 times delta theta. And in this case, it's going to be 0.75 times pi. Rather, sorry, this is going to be, this delta alpha here actually is 90 degrees. So this would be pi over 2. So delta theta changes from C to D. So in part C, it's again 0.75 pi, but in part D, it's going to be delta theta is going to be pi over 2. And then at this point, we can say that our tan of phi rather, is going to be pi. And phi then equals arctan of pi, which is 72.3 degrees. So phi equals 72.3 degrees, and this is the angle between the linear velocity and resultant acceleration. And this would be your answer for part D. And that's the end of the solution. Thank you for watching.